It's me again, Wes Purvis. And this 10 talk, I want to talk about using AI to simplify Wi-Fi configuration and operations. So let me just level set on some definitions, because I think that there's a lot of misperceptions out there and a lot of confusion about what AI, machine learning, deep learning, all these terms, what they actually mean. So first, artificial intelligence. In a nutshell, this is the ability for a machine to do human-like things. And so that's very high level. It's an easy definition. And I'll go through some examples later, but that's all it means. It's nothing more. So next comes machine learning, and this is the ability for a machine to learn on its own without being specifically programmed. So this is the ability to look at a data set and train itself on that, or just through normal operation be able to train itself and change its behavior. After that is deep learning. Deep learning is really where we want to get to in terms of this whole journey. It's very difficult. It builds on AI, it builds on machine learning, uses neural networks and to really create a smart machine, essentially. And this would be probably the closest to Skynet, if and when we get to that point. And then kind of related is data science. And so this is a term that will be used to basically define working with data and coming to some sort of conclusion. So let's what are some examples? Anybody have an idea of AI?
In wireless?
Or in general, in any context?
Oh, many, but in wireless specifically, we do resource management would be an example.
It could be, yeah. So RRM could be an example of
automated IVR system.
Sure, yeah. In in consumer type devices, one example could be Alexa. You can ask Alexa a question, Alexa will answer you. By definition, that is machine learning. You may not always get a great answer, but it's getting better, right? Machine learning example would be Nest. So Nest learns when you are home and when you're not home, and changes the behavior based on that. Deep learning, so eventually this could be Tesla with your self-driving cars, completely autonomous, being able to learn road conditions and all that kind of stuff. We're on the journey there. We're not there. Data science. For those of you that follow any American sports, which why would you? We're in the midst of professional baseball, the postseason, and last night the Boston Red Sox beat the New York Yankees to advance to the ALCS. And so data science the idea of data science, you'd be able to look at data and data science will make a prediction on who would win, between the Yankees and the Red Sox. So how can we use these in Wi-Fi? There's a lot of examples out there, in location, to be able to calibrate a network, troubleshooting, detecting issues, that kind of stuff. RRM, as was already brought up, using AI as a modern CLI, be able to ask questions. Auto configuration. Maybe eventually, if I think the barrier here is people becoming comfortable with an auto configuration, and also baselining. And this is what I want to spend the rest of the presentation on. I thought that yesterday there was a great 10 talk by Alexandra on notifications and the whole SRE, being able to identify issues and getting notified on that. And so that's what I want to talk about. So what is baselining? So baselining is the concept of figuring out what is normal on your network. And that will change for every network, and it'll change over time. So it's important for you or a system to understand what is normal on your network, to be able to detect, and most importantly, in my opinion, notify when there's an anomaly, when something is outside of the baseline or outside of normal. So it's important to look over time and look at several factors. This screenshot that I'm showing is what we used to train our RRM algorithm, which is, this is the neighbor relationships of every single MIST AP in the MIST universe. So you can see how strong the neighbors are, how frequently those neighbor relationships are occurring. So let's talk about the current state of anomaly detection. So this is being notified of an issue. So this is a typical up-down monitoring. So is a system or service up? You get a notification when a system is down. How many emails do you get from something like that in a large organization? This is a network administrator's email box of 1,300 automated notifications from syslog and SNMP just over the past week. He sent this to me on Monday. This is alarm summaries. What do you do with this? Once you get to this number, you kind of just have a fatigue of notifications and alarms. You just kind of ignore them. And my personal favorite. You get to the maximum number of notifications and it just says 999 plus. My employer isn't innocent in this. There are many times where we over-notify. I think it's something as an industry that we can and should get better at. However, it's challenging. Understanding what is normal and what is not normal on a network is challenging. So this is over time, successful connections in a network. The top graph is over a longer period of time. The second graph is more of a zoomed in look. And so as time goes on, as you go to the right, the failure percentage will rise, right? Because the number of successful connections is going down while the number of failed connections is remaining the same. So it appears like the failure percentage is rising. So what happens? If you set a static threshold every single time, so this would happen to be every single night. What's actually happening here is, during the day, people are on the network, lots of clients. At night, there's so many clients that are left there and they're, in some sort of bad state, whether they're, haven't been used and they have a wrong password or something like that. So it appears like there's an issue on the network. And if you set a static threshold, you'll trigger an alert and it's a worthless alert. It's not going to do anything for you, and you're just going to learn to ignore that alert. So what is the solution? You have to get smarter. You have to look at many different factors and over time to understand what is actually happening on the network, what is normal and what is not normal. So first you have to identify an anomaly. So identifying an anomaly is something that's outside of the baseline. And then once you identify the baseline and identify the anomaly, you have to notify. This could be an email, this could be a Slack notification, this could be a pager duty. This could be anything that you want it to be. And finally, you have to take action on that. And whatever that action is, you know what the issue is, you can then go address it. So in this case, it was a DHCP issue where the DHCP server wasn't responding to requests. So that is it for me. Summary is, I think as an industry, we can and should get better at detecting real issues and learning on them so that you don't have notification fatigue where you're just ignoring your notifications. And when a real issue actually occurs, you don't know because you've ignored. You have to wait for your users to actually tell you. So thank you.
Thanks.